Very good. So our hypothesis is our if section. What's our conclusion? The then section. Very good. Any questions on number 1 and 2 of today's warm-up? All right, number 3. We are actually looking for the measure of angle 1 and the measure of angle 2. Does anyone know one of those and why? Let's focus on number 1. The angle we're given and number 1 are what type of angles? Nope. They are corresponding angles. You notice that they're in the same position when compared to the intersection point. They're both like upper left. All right, so they are corresponding angles. What do we know about the measure of corresponding angles? Corresponding angles are congruent. So this one is also 103 degrees. Now, once you know that angle 1 is 103 degrees, you can actually find the measure of angle 2 in 2 different ways. Does anyone know one of the ways? Well, let's focus on the angle we were given. This guy and this guy are what type of angles? Nope. Nope. Alternate exterior. What do we know about alternate exterior angles? Right. What do we know about their measures, though? They're the same. So this one is also 103 degrees. The other way to do this would be to notice that angle 1 and angle 2 are... Do you remember what those are called? They're congruent. Why are they congruent? It's something we actually learned last chapter. When they're formed by 2 lines that intersect. There, starts with a V. Huh? What? Not horizontal, but... Oh man, you guys. Vertical angles! 1 and 2 are vertical angles, and vertical angles are congruent. Woo! You guys got too much sleep last night. V. No? Sorry. All right. I'll give better hints in the future. My bad. Any questions on number 3? You guys. All right. Number 4. Let's see if we can do a little better on this one. So, we are still looking for 2 things. We are looking for the measure of angle 3 and the measure of angle 4. Pick one. Anyone have one that's like jumping out at them? Angle 3. Do you know what angle 3 is? 3 and 4 are same side interior, but let's focus on 3 and the one we already know. These are... They're alternate interior angles, and I heard someone else say they're congruent. That is true. Alternate interior angles are congruent. So angle 3 is 72 degrees. Again, just like last time, there are 2 different ways we could actually think of finding the measure for angle 4. Both of them involve the same process. But angle 4, can anyone think of how we could find its measure? One way you've known for weeks and weeks and weeks, one you just learned. They add to 180. What's they? Huh? Which ones? 3 and 4. Okay, that's the newer method we learned. 3 and 4 add to 180. How do you know that? They're same side interior angles. Very good. So if you do 180 minus 72, you'd get 108 degrees. That's the new way. Can anyone think of the old way? It involves this 72 instead of this 72? Divide? No. No. What type of angles are these? Let's just quit yelling out math words and talk about what type of angles these are. No. This is before we learned anything about transversals. Yeah, this is a straight angle, right? What do straight angles add to? 180. So you need to do 180, take away the part you already know. That'll give us the part that you don't know. Which still gives you 108. Because mathematically you're doing the same thing, but the reasoning behind it is a little different. Whew, that extra hour of sleep didn't do anything good for you guys. Just kidding. Alright, any questions? You all awake yet? You should be like extra raring to go today. No? Didn't even want to come. Well, I'm glad you all made it. Anyone need more time with this warm-up? Alright, here's our lesson for today, so get your notebooks out. I'll get those warm-ups in just a second. Let me explain to you how this is going to work. So today we are going to start this lesson, lesson 3.5. It is all about showing lines are parallel. Our objective is to show two lines are parallel. We'll talk a little bit more about this lesson in a second, but I just want to give you a preview of what the next 2 days are going to look like. We are going to start this lesson today. We are probably only going to get through a couple of examples. Then we're going to take some time, go over that quiz you guys took yesterday. So that's what's going to take up most of class today, is just the first few examples and then going over your test. When you walk in here tomorrow, we are not starting a new section. We are continuing this section right where we left off. So there won't be a warm-up on the board, there won't be a new title and a new section number and all that stuff. You won't have any homework to turn in. It's going to be like we just pick up right where we left off, okay? So you're going to have one big long section of notes, but it's going to be over the course of 2 days. Does that make sense? Okay, so here's what we're doing today, showing lines are parallel. Today's lesson is actually kind of like opposite of what we did before the quiz. Before the quiz, I would say, hey, these two lines are parallel, and then I'd ask you questions about the angles that were formed by the transversal. Now you're going to get information about the angles, and I'm going to say, well, are the lines parallel? So we're kind of doing the same type of material, but in reverse. So it's kind of fun, especially if you did well on your quiz. You'll probably like this lesson a lot. But again, we're going to do a little less than half today, actually, and then we're going to jump right in tomorrow. You will have homework tomorrow, but not today. All right, I want you to start today's notes by writing this definition down. This is a converse, similar to the shoe. A converse is an if-then statement. The converse of an if, sorry, I can't read today. The converse of an if-then statement is the statement formed when you switch the hypothesis and the conclusion. After that definition, I want you to write the words flip, flop. So the reason I put this big shoe up here is because Converse is a brand of shoe, right? And flip-flop is a type of shoe. So I want you to think Converse, shoe, flip-flop. Okay? Because the Converse, you're taking the hypothesis and the conclusion and you're switching them around. You're flip-flopping the order. Okay? So again, think Converse, shoe, flip-flop. I need to flip-flop the hypothesis and the conclusion. Now, sometimes the converse is true, sometimes it's not true. That's half the fun of it. All right? So, again, Converse, shoe, flip-flop. You're going to take the hypothesis, make it the conclusion make it the hypothesis. Alright, so you don't need to write this down. Like I said, this is just a quick sort of example of what a converse is. So when you're finding the converse, the first thing you want to do is identify the hypothesis and the conclusion. We're going to leave the if and the then part out because the if is stuck in the front, the then is stuck in the back. If you switch the if and the then, it won't make any sense. You can't say then this, if this. You got to keep the if in the front, all right? So in this one, the hypothesis is if I live in Belleville. Okay, so we're just going to focus in on the I live in Belleville part. Then I live in Illinois. So the conclusion is I live in Illinois. Is this true? If you live in Belleville, you live in Illinois?
Yes.
Yes. Okay. Now, the converse, we actually flip-flop them. So the part that was the conclusion, I live in Illinois, is now the hypothesis. The hypothesis, I live in Belleville, is now the conclusion. So again, you just take them, flip-flop them. Now, sometimes these are true, sometimes they are not true. So is the converse true here? Can you give me a counterexample? You remember what counterexamples are? Examples that prove you wrong. So can you think of an example that proves that wrong? If I live in Illinois, then I live in Belleville. What's a counterexample?
It's what everybody thinks.
That's immediately what your brain goes to, is the counterexample. I'm a counterexample to this statement.
If I live in Illinois, then I must live in Chicago.
Right. Yes.
That's what everybody thinks.
Anytime you travel, yeah, if you say you're from Illinois, they assume you're from Chicago. Yes, very. And you could say, no, because I live in... You'd say any city but Chicago. Same thing here. Any city in Illinois besides Belleville proves this to be false. So this is actually a converse that is not true. Alright, so you're going to have two things to do today. You're going to have to write the converse, and then you're going to have to decide if it's true or not true. So I live in Columbia, so I am a counterexample to this converse. But you don't really have to go that far. You can just say false, because there are many people that live in Illinois that do not live in Belleville. What are your questions for what's on the board?
So which one is...
Here is our first example. For this first example, I do want you to write the if and then the converse. For the next one, you can just write the converse. So go ahead and write this down first. We'll write the converse together, and then we'll say if it's true or false. All right, so what is the hypothesis for the statement on the board? Good. So the part we're going to move around is the two segments are congruent. What's the conclusion? Very good. All right, so I always want to start with if. Don't move the if. But then you want to flip-flop them. So this one goes up here. That one goes down there. All right, so if two segments have the same length, comma, then the two segments are congruent. Sorry, I sort of ran out of space there. So remember, converse just means flip-flop. So I took the conclusion I made at the hypothesis. I took the hypothesis I made at the conclusion. So our new statement says if two segments have the same length, then the two segments are congruent. Any questions on that part of the problem? Next it says to determine if this is true. Is this true?
Yes.
Yes, this one is true. If they have the same length, then they are congruent. What are your questions? All right, here's example 2. I don't want you to write down the problem if you have one complete example problem and answer. But on these, you can just write the converse for number 1, then state if it's true or false. Write the converse for number 2, state if it's true or false. I want you guys to try these. I'm going to give you about 3 minutes to do all of them. So 2 parts of the 2 problems. Write the converse, say if it's true or false. Write the converse, say if it's true or false. We'll go over them in just a couple minutes so you can see if you're right. So by the time I'm doing them on the board, you should already have them done and in your notebooks. This is actually the last example we're going to do today. So after these 2, we will be done for your notes, but your notes will pick up right here tomorrow. So make sure you bring what we did today tomorrow so you can just continue the notes seamlessly. All right. Anyone want to tell me the converse for number 1? If very good. If the angle is acute, then the measure is between 0 degrees and 90 degrees. Now your wording might be a little off, but that is the main gist of it. So if the angle is acute, then the measure is between 0 and 90. True or false?
True.
This one is true. Very good. Any questions on that one? Let's focus on number 2 now. Anyone have the converse? What's that symbol? You should all know that symbol by now. What is it? Then angle 1 and angle 2 are vertical angles. Is that true? Someone give me some reasonings. I hear both answers. If angle 1 is congruent to angle 2, then angle 1 and angle 2 are vertical angles. Let's see if we can come up with a counterexample. Can you think of any time that angle 1 and angle 2, or any 2 angles, could be congruent that aren't vertical angles? Are vertical angles the only time they're congruent? For this to be true, it has to be true every single time. So every single time 2 angles are congruent, they're vertical angles. What about two right angles? We just learned that all right angles are congruent. Are those vertical angles? No, vertical angles are the ones that look like this, remember?
Okay.
So all angles that are congruent look like this, is what this number 2 is saying.
Oh, so you
No, that's not true. You can have lots of different congruent angles that are not vertical. So all vertical angles are congruent. That's why the original statement was true. But all congruent angles are not necessarily vertical angles. So this is not true. Or false. I've said this several times. I'm going to say it again. Your notes will pick up right here tomorrow. So bring those notebooks in. Be ready to sit down and work. We only have 40 minutes again tomorrow. We have a whole lot more to do for 3-5 plus some homework. All right, so we got to get right to work. Any questions?